Our Flet application currently stores the information about the character in a Python class. The Python class allows us to store things like skill, luck, and stamina specific to a character. And there's additional information with the name that we can connect together. However, the Python class can be a bit verbose. Today we're going to look at the data class, which is a standard Python library, to make this a little bit easier to read and to deal with. Let's look at the Python data classes. Here's our current code. So you're probably wondering, what do you really need self? Do you need all of this boilerplate code? Because the meaning of it should be pretty straightforward. We're going to use a data class. It's a decorator, so the things with the asterisk at the front are decorators. And it's going to automatically generate common methods for us. So there's this automatic init generation. This is the init. There's a representation, string representation, which we'll cover, as well as equality comparison, which we'll cover. So we're first going to import the data class from the Dataclasses module. From Dataclasses, import data class. Let's just do it. Data classes, import data class. Step 2, add the data class decorator. Let's just drop it in right here. And remove the init function, which we do not need. So we're going to follow this format here, and some of them, so this is positional, comes first, and then the ones that have a default value will come after that. So we removed quite a bit of code here. The standard Python class is actually a little difficult to read. We're also not using this asterisk here. And we reduced it from 18 lines down to 7. See if it still runs. It's amazing. No changes to the code. After that, this plugs right in as a direct drop-in replacement. So we do get this init, this representation string, and an equality mention. No changes to the code. You instantiate it exactly the same way. In the original Python class, there is this asterisk here, and then everything after that specifies that it's keyword only, meaning that you have to do skill equals some number when you instantiate the object. But with the data class, you don't have to do that. Our class had the correct order that was required by the data class. The string is the default. This name is the default, and it's required. The rest of these are optional. In the data class, you can't do something like this where you have the string being default, and let's say that the image path did not have a default, right? So there's no equal sign there. This would raise an error in Python. So let's try to print out one of these objects. You can see that it nicely prints out the object right there. It's human readable. If you've tried to print out an object before, you'll see something like this, which is difficult to figure out what is inside the object. Although by default from Python, you do know that it's a character object, so you can figure it out. It's just easier to read when you're trying to debug it. So normally you wouldn't be able to compare two different characters, even if they had the exact same fields, because the objects are actually different. However, there's this equality method here. Let's add another match. We'll make him identical, a clone. You see that when it reruns, we have our string representation here, easy to read what the contents are, and also we can check to see if the contents are the same. No changes were required to the code to instantiate the characters. And there's other nice features with the data class, such as the ability to freeze the data class and make it immutable. And there is a field in the data classes. So this seemingly, it's looking kind of complex, and you're probably thinking, why not just put the square bracket here to make the list? But if you do that, each instance of your character will share the same list. So this prevents a really common bug in Python where, if you were to have a dictionary or a set or a list here and you didn't use this convention, it would share, each instance of your character would share that same list, dictionary, or set. So we're using the data class because our class for the character, it primarily stores data. It was kind of hard to read because of the boilerplate code with the class, and we wanted to make it easier to read. It's a standard Python package here, so no third party is needed. Then we have our nice looking class here. We didn't need these, so we're not using a string representation, equality of the objects in our code, but we did want to make it easier to read. If you do need to do equality between two different objects, you should use it. If we were to extend our class with more complex initialization logic, we wanted something to happen at time of initialization, or there was more behavior in it. There's no behavior right now. We don't have the character to run, move, and other things for the behavior. So for our simple class here, the data class is actually a good fit. And it's quite widely used. It's part of the standard Python library. So there's no reason to use the self type of convention. So you can reduce the boilerplate code significantly, make it more readable, and it's the best practice. It's commonly accepted to do this for these cases where the class you're creating is mostly data. You get all these great benefits from init representation, string representation, equality between two objects. It forces type hints, which is great. So in this class, we are encouraging the use of type hints. It works seamlessly with existing code. In our example, it was a drop-in replacement. No additional changes were needed other than for that one class.